Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for December 3rd of 2025 is titled Visualization Near a Black Hole and Disk. So what do we see here? Well, here we see a visualization looking at what we would see if we were plunging toward the center of our galaxy. So this is a model that then puts together what we would see based on the laws of general relativity. So if you were to be plunging toward a supermassive black hole about 4 million times the mass of our sun. Now that's about the mass of the black hole at the center of our galaxy. So that's why we're using this. And we would be traveling toward it at a very rapid rate. In fact, about 60% of the speed of light. So we're zooming right toward the black hole. And what would we see? Well, here we get an image of what that would look like. And we can see our own Milky Way galaxy in kind of a loop there. It's all distorted because of the intense gravity around this black hole. We can also see an image of the Milky Way down below. So you'll see where it's labeled image of the Milky Way. That is also our Milky Way. Now that's because the light follows a very distorted path when it travels near a black hole. Essentially, the black hole warps space and time around it, and the light no longer travels in straight lines like we're used to. It travels in the shortest path in this highly distorted space. And that means we can sometimes see it come from different areas as we do here. So we see our Milky Way. Down to the lower right hand side, we can see where it's labeled SMC and then LMC closer to the center. Those are the Magellanic Clouds. And those are satellite galaxies of our Milky Way. We see them, and we also see images of them just below the center labeled as well. So everything gets so distorted that we will get multiple images of various objects. We see this when we look at things in the sky. And here we get an image of what it would be like if we were traveling rapidly toward the center of our galaxy. Now we also see the bright region at the center is the accretion disk, that line going across. That is the disk of material spiraling around the black hole. And it gets heated up to very high temperatures. This is approaching a black hole. It's being accelerated at a very high rate. The friction will heat things to high enough temperatures that you will give off things like X-rays. And we can see that hot material as it spirals in toward the black hole, but we can see how it stretches all the way across the image here. Now, the other thing that we see in the center is that it gets a lot brighter. And in fact, that is because of Doppler beaming. And that is an effect of relativity as well. And we're going to see in the direction of the motion, the direction that disk is moving, it is going to be brightened. So it'll dim and away from the direction of motion, and toward the direction of motion, it will get brighter. Now, the other thing that we see is that little loop down below labeled photon rings. Those are, in fact, images of the accretion disk that we've just looked at. And that's because these photons, we tend to think of photons, light particles, as moving in straight lines. They don't do that near the black hole. So we get multiple distorted images of that accretion disk because the photons don't just travel in straight lines away. They are going around the black hole and can come back and see them from many different directions, giving us the interesting pattern that we see here today. So this is what you would see were you traveling toward the center of our galaxy at nearly 2/3 the speed of light. You would see all of this unusual distortions associated with that supermassive black hole at the center of our galaxy. So that was our picture of the day for December 3rd of 2025. It was titled Visualization Near a Black Hole and Disk. We'll be back again tomorrow for the next picture, previewed to be Galaxy in the Furnace. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.